तो गाइस इस वीडियो में इस लेक्चर में बताने वाला हूँ प्रोबेबिलिटी ऑफ सीएमएमएस डेटा साइंस। और इस लेक्चर में स्टार्ट करेंगे प्रोबेबिलिटी से और देखेंगे क्या क्या है। तो प्रोबेबिलिटी में अगर टॉपिक्स की बात करें तो बहुत ज़्यादा एडवांस टॉपिक तो नहीं है। तो पहले आपका बेसिक प्रोबेबिलिटी है, बेसिक प्रोबेबिलिटी। उसके अलावा कुछ कॉन्सेप्ट हैं रैंडम वेरिएबल्स के। और बेसिक प्रोबेबिलिटी में आपके बेस थ्योरम और कंडीशनल प्रोबेबिलिटी, कंडीशनल प्रोबेबिलिटी ये सब भी है। इसमें रैंडम वेरिएबल्स और इसके अलावा रैंडम वेरिएबल्स से कुछ प्रॉपर्टीज़ हैं और उसके अलावा कुछ स्टैंडर्ड डिस्ट्रीब्यूशन है। तो ये सब चीज़ें जो होगा स्टैंडर्ड डिस्ट्रीब्यूशन सब चीज़ देखेंगे। और पहले हमारा फोकस ये होगा कि हम बहुत ज़्यादा प्रोबेबिलिटी के डीप में ना घुसे, बल्कि प्रोबेबिलिटी को इस तरह से पढ़ पाएँ कि हमें पता चल जाए कि क्या टॉपिक्स हैं, कौन से ऐसे क्वेश्चन है जो कि आप सॉल्व कर सकते हैं प्रोबेबिलिटी के टॉपिक से। सो लेट्स दिस वीडियो स्टार्ट एंड लाइक इन प्रोबेबिलिटी जस्ट इफ यू स्टार्ट फ्रॉम द बेसिक थिंग, द फर्स्ट थिंग इज अबाउट द sample space. Okay, so if you just understand the sample space, that's okay. So like the set of all possible outcomes of a statistical experiment is called sample space. So let's say you want to conduct an experiment, okay, and you want to conduct an experiment. So in statistics, everything is termed as experiment. So that the things you want to do, like tossing a coin, throwing a die, everything is a experiment. So the thing is that a set of all possible outcomes of a statistical experiment. So whenever you conduct experiment, you have some possible outcome. So let's say you are tossing a coin. So coin, tossing a coin has a outcome that either the coin will result into head or it will result into tail. So these thing is actually represented in the curly bracket. Okay, so this is a set. This is a set thing, and this is represented in curly bracket. So this is saying that the set of all possible outcomes of a statistical experiment is called sample space. So this is the sample space and is represented by the symbol S. So simply the same sample space is any outcome of experiment. The second point is that each outcome in a sample space is called an element. So this is called the element of sample space or member of sample space. So the H or T is called element or member of the sample space. Now, if the sample space is a finite number of elements, we may list the number separated by the commas and including the braces. So this is how, if you have a finite elements in a sample space, you write this thing. You just write a curly braces, what are the elements separated by the commas, and and then you can close the curly bracket. So this is how you write it. So means I told you if I were tossing a coin, then head and tail can be the two possibility. So it's all about all the possible outcome. Okay, so let's say you are throwing two die. Okay, you are throwing two tossing two coin. So in that case, what will happen? That what is the possible what is the possible sample space? Okay, so sample space is the set of all possible outcome. Okay, so in that case we know that if you have set of all possible outcome, then tossing a two coin result into two different scenario. Okay, so let's say this is a coin one, this is a coin one. So either it can result into head or tail. Okay, and this is coin two, coin 2, and this can also result into either head or tail. Okay, now this way if you're tossing a coin, it may happen that the first position is head and second position is tail, or it can follow other direction also. So if you want to consider all such possibilities, what are the all possibilities that you need? Okay, so let's say we have a head, then other coin can be tail. But if you have first coin as head, other coin can also be head. Similarly, it may happen that the first coin is tail, then the second coin is also tail. It may happen that the first coin is tail and second coin is head. So this is all the possibility, all the sample space that you have if you're tossing two coin. Similarly, tossing three coin will result into some similar thing. So let's say you're tossing three coin, then in that case sample space will be, we know that if tossing two coin result into all these types of possibility. Now what happens that tossing three coin can have additional head in case of all these positions. Okay, and additionally tail in the case of all such position. So you may think that you can see that the size of S is actually increasing. So if any experiment has uh, so like this has four element, this has eight element, and similarly the size will grow. So we'll see some formula actually later. And so this is how we actually find the sample space of any experiment. Okay, so let's now consider some complicated example, and like this type of questions can be formed in the probability based on this type of sample space. So we know that tossing a die. So tossing a die means a die is a six face, like six face figure. three-dimensional figure, and there's a number printed, dot printed on each side of the die. Okay, so this thing is the there. Okay, so the thing is that if you're interested in the number that shows on the top of face, the sample space is S1. So let's say you are considering a thing where you are throwing a die and saying what is on the top of the face. So it may happen that it is a one dot, or it may happen that it is a three dot. So whatever the number we're considering, so let's say you are only considering the number that is on top of the page. So any possible, what you can say, any possible experiment can result into either of these number. Okay, it can result into either of these number, either it will be 1 2 3 4 5 or 6. But let's say you are interested in checking whether the number is even or odd. So any number that will occur out of this thing, uh, either it can be even with a 2 4 or 6, or either it can be odd with 1 3 and 5. So we have only two outcome. The sample space will be either even or odd. Okay, so the thing that you want to observe actually decide your sample space. So it's not the thing that if you're interested in only whether the number is even or odd, then you will have three outcome or four outcome or six outcome. No, no. You have just only two outcome. Either the number will be even or either the number will be odd. So this is the two possible outcomes. So this is the sample space. Okay, the next thing is that key experiment consists of flipping a coin. So let's say you have a coin and you flip the coin. So this is the coin and you flip the coin. So this is the first step. And we know that the flipping the coin can either result into head or either result into tail. Okay, this is the first step. And then flipping it a second time if a head occurs. So you are having coin, so you toss the coin. Okay, if it's a head, you again toss a coin. So if it's a head, you again toss a coin. So this is the second outcome. Okay, so if it's a head, you again toss a coin, and that can also result into either head or tail. And the third thing is that if the tail occurs, agar tail hua, then on the first flip the die is tossed once again. So if the tails occur when we cross a die, so it means that it is a multi-step experiment. The first to toss a coin, head or tail. If it heads, you again toss a coin. So either it can be head or either it can be tail. Or if it's a tail, you toss a die. So it can have six possible outcome. Okay, so six possible outcome: 1 2 3 4 5 6. So this is how it has been represented using this diagram. So if you just consider the sample point, okay, what is the sample point of this experiment? So to understand the sample point, you need to collect all those particular things. So you know that either it can be HH, or it means the result of experiment can be HH, means the first is head, then also second is also head. Either it can be S tail, first is head, the second is the tail. And either it can be T1 means you have a tail and you toss a die and you get one, or T2 T3 T4 T5 T6. So these are all the possible sample space of this particular experiment. So like it may happen that some particular time it may again grow also. So let's say head coming again may throw a dice or throw a coin, or pull a deck of card. So anything, any possible such thing can be possible. The main thing that you need to do is whatever the final conclusion you want to make, whatever the final sample point you are making, that thing actually be by collecting all the possible outcomes in the earlier steps. Okay, so this is how it's actually represented by using this diagram. So now we will discuss about the events. So we talk about the events. So sample space, like your whole universe, whatever the possible outcome. But probability actually is defined on event. So you have some event which is the actually subset of the sample space. So let's say na, ki you have tossed two coin, and you have got this particular thing as uh, your sample space. Okay, and you now want to define an event. So event is any possible subset. So let's say we define event E1 as which itself a set, head and tail. Okay, so this is an event. So any possible subset of sample space is an event. So like in this case particularly, there can be a lot of lot of lot of events actually, because there can be a lot of subset defined. So like subsets, set is one thing. Set is like this ABC set. And subset means, if you don't know about subset, so subset means any combination of elements. So like just to choose two element, A or B, so this is a subset. Or maybe you choose only A or C, so this is a subset. Or maybe you choose only A, so this is also a subset, because these all elements lie in this particularly first parent set. Okay, so these are all subset of this first set. Okay, this is what the Event means, so event is if you take any subset of your sample space, it will be an event. And actually probability defined on event, like let's say we have written here, apart from this particular thing, this particular sample space that we have, we may ask yourself, okay, what is the event that there will be two head when you toss two coin. So this particular thing is there, and you actually define a probability based on the event only. Okay, so let's see how we can do that. So event means any particular subset. So maybe you can define an event, and you can may say that at least event is at least one head. So in that case, we know that at least one head means whenever you are tossing two coins, either it can result into one head or either it can result into two head. So one head means this particular thing actually has one head, and this particular thing is actually had two head. So in that case, E1 sample event is actually having HH, ST, and TH as its element, and which is actually a subset of this sample space. So this is how we construct, like subset of this particular thing, and this is called event. Now complement of event, so like this thing is actually set, so there can be a lot of operation defined on the set. So complement of an event means, if you have some sets, first let's say what's the complement of set. So let's say A is equal to A B C, okay, and your S is equal to, let's say, A B C D and E. Okay, so if A, like A is the subset of A, so complement of A means all the element that belong to S but that does not belong to A. Okay, so here A complement is written as A dash, or sometimes A complement is also written as AC, or sometimes A complement also written as A bar. Okay, so this thing actually means all those elements. The complement of event A with respect to S is a subset of all element of S that are not in A. So in this case, we say that D and E are not in the A. So D and E will be the subset of, what you can say, complement of this particular A. In this case also, E1 complement it as E1C is equal to all the element that does not belong to E1 but does belong to S, which is TT. So this particular thing TT is the complement of an event. Similarly, intersection of two event A and B. So intersection of two event A and B is denoted by A intersection B, and the event contains all elements that are common to A and B. So this is what intersection of event is. So let's say you have S is equal to, okay, let me just change the color. So let's say S is equal to this particular thing, head tail, tail head, and tail. Okay, and let's say we defined event even as, even can be defined as event as head and tail head, and let's say E2 is defined an event as head tail head and tail. Okay, so in this case we can say that we have two different event. So intersection means E1 intersection E2. This particular event means all the elements that are common to both E1 and E2. So both are that are common to both event. So you can see that this particular th common. So this th will be the intersection of this particular thing. So in E1 intersection E2 result into this particular element. Okay, also intersection of two events A and B can be, like it can also be intersection of three event. Like it may happen that sometime you have three event, E1 intersection E2 intersection E3. Okay, in that case just see all the elements that are common to both E1 E2 and E3. So in that case will be the intersection of E1 E2 and E3. Okay, but that's not only the end. You can actually, like in the particularly set theory, there is something called Venn diagram, and using the Venn diagram you can actually easily visualize this particular thing. So what I was trying to say is that, okay, let's say you are trying to figure out whatever the intersection and particular thing are, so you can do this thing. Okay, so let's represent this particularly large set by S. So this is your set S. Okay, and this is a event, all those sample point that is lied in the event A, and this is event B. Okay, so like this common area, we know that this common area, whatever this common area is, and we know that the intersection of two event is whatever the commons is between A and B. So in that case, you can see that this particular common thing is actually A intersection B. So this is A intersection B. Okay, so this is, like these particular things are actually represented by using the concept of Venn diagram. But this is not only that. You can also see that we can also represent here this particular thing, A complement. So you can see that this particular whole everything is A. This red circle is A. Okay. Apart from A, everything that lies in this inverse, everything that lies in the inverse, S is actually A complement. So A complement can also be written as uh, so this A complement is all those element that is in this set S, but that is not in A. Okay, so this can be represented by this area. So this is the way you can actually like represent complement of an event, intersection of event. Sometimes you can also represent union of event. So what is union means everything that is in A, everything that is in B, and everything that is common between A and B. So this thing actually written together, and this is called A union B. So this is union of two event. Okay. Now mutually exclusive event. What is this two event? Two events A and B are called mutually exclusive event if or disjoint event if A intersection B is phi. That is A and B has no common element. So like mutually exclusive is actually a very general term that is used in the probability thing, and most of the time you will be actually getting to learn about this particular mutually exclusive event. So that's why I'm telling you, if you're learning about mutually exclusive event, the main thing is that you need to pay attention to A intersection B. So let's say A is some set. Okay, A is some set 1, 2, 3, and B is some set. Let's say 4, 5, 6. So we can see that this particular, if you find A intersection B, it will have no element in common, and that is particularly written by this particular symbol phi. Okay, so that's why it is called mutually exclusive or disjoint event, because if two set had don't have any elements column, this is termed as mutually exclusive event. Also, in real life, also you can see an example like tossing a die. You are tossing a dice, and E1 is the event of even number, and E2 is the event of odd number. So even will result into elements such as 2, 4, 6, and odd result into elements such as 1, 3, 5. So in that case, you will never have any common element. Okay, never have any common element. So this is how complement of event, intersection of event, and mutually exclusive event means in the probability. And we actually define these things on events only. An event is a subset of sample space. Okay, so this thing actually turns into probability definition. So probability of any events happening is equal to number of ways it can happen by total number of outcome. So total number of outcome means this is the size of sample space, size of sample space. Okay, sample space, and number of way it can happen with whatever the size of that particular event is, size of event. Okay, so we will see what is size or this particular thing is. So but overall, the overall main idea is to define probability is probability of any event is number of ways it can happen and total number of outcomes. Okay, so especially we are talking about some very simple definition, but when you will join masters in particular college like CMI or ITs, you will actually learn some other definition of probability, and that will be totally different from what you know, but the way we calculate probability will be the same, but the definition will change. So that is called omega FP distribution. Definition, and this will be actually different from what you know. So this thing is not of our interest, because this we should not complicate this thing, because simple thing will let you to understand and solve the questions that you want to. Okay, so simply number of ways it can happen, any event that can happen, and total number of sample space, which is it is a part of. So let's say talk about the example. A coin is tossed twice. Okay, a coin is tossed twice. Tossing a coin will result into the sample space of, what is the sample space? We know that head, tail, head, tail, not head, head. Okay, so this will be the sample space. So what is the probability that at least one head occurs? So this event, at least one head occur is the is the event. So at least one head occur. This is the event E1. Okay, this is the event E1, and this is the event. So you can actually write this thing by the capital letter only. So this is the event E1, and you need to find the probability of event E1. Okay, so this is how it is written. The probability of happening of an event E1 is equal to number of ways it can happen. So at least one head occurs result to which element? So at least one head occurs result to this particular element, head, tail, this tail head, and at least one head. So okay, so this double head is also there, because at least one head means either there will be one head or either it can be more than one head. So head, tail head, and head head, and this is resulted into this particular set. So it is saying a number of ways it can happen. So there is only three way it can happen. Number of ways is three. So we write three, and number of outcomes. So total number of outcome or the size of sample space is four. This is 3 by 4. So this is the required probability you have for tossing a coin, and probability of finding that at least one head occur. So simple thing is that just try to write the event, whatever the event is, and just see what is the size of event and sample space, what is the size of sample space. But things get complicated when you try to incorporate more events into the action. So let's see how those things happen. Okay. So first, the thing is that you can always solve some questions based on the probability. So let's say you are tossing a dice, and you are seeing the outcome of having a number greater than 4. Okay. So this is you will have some I don't know, like you will have some event, some sample point in the event also, and this is a subset of event, the larger event. Okay. So these things you can always do, like trying to incorporate some experiment into the probability, and let's see and see how you can find those things. Okay. So any particular experiment you can just result into some probability. But the thing is that what happen, you have just two events. So let's say there is two event A and B. So you have two event. Then A union B, just let me define the first A union B. So let's say this is particularly your sample space. This is your A and this is your B. So in this case, the A union B is defined as all the sample point that lies within A and B. So let me just define in the terms of set. So let's say A is equal to 1, 2, 3, and B is equal to now 2, 3, 5, 6, 8. Okay, so these are the all the eliminators in A union B. So A union B means all the points that is in A. So in 1, 2, 3 is actually in A, and all the point that is in B. So in B, 2, 3 is always already there. So we don't need to write the same thing twice, and then add the same element that is left in B. Okay, so this is what A union B means. All the element that is in A and in B, and all obviously those elements that are in A and B both, that will be included, because this 2, 3 is always be there, because this in both A and B. But you don't need to write the element that are common twice. Just write those element in once. Okay, so this is how A union B is defined. So in terms of probability, let's see how you define the A union B, and what how you can calculate the probability if you just to have two event. Okay, so the simple thing is that if you have two event A union B, then probability of A union B, I have written the formula, is equal to probability of A plus probability of B minus probability of A intersection B. Okay, so this is how you actually calculate the probability of two event. If A union B probability need to find, just find probability of A, probability of happening event B, and then probability of A intersection B. Okay, so you may ask that why this particular thing is happening, why we are minusing this particular thing. So you can see that if this is A and this is B, so we need to find the probability of A union B. But particularly this thing, this common area is actually counting there twice. It's also being counted in the A, and it's also being counted in the B. So that's why we need to remove this particular area. So this is counted twice. So that's why we do it minus one times, which is intersection, and now we have probability of this particularly A union B. Okay, so this is how you can just understand this intuition how this probability of A union B is counted. Okay, so if you just talk about example, so let's say A is an event of any example you can just pick up. A is event of so let's say we're tossing a die. So tossing a die will result in sample space of 1, 2, 3, 4, 5, 6. Okay, and let's say A is the event of number even number. Okay, uh, even number, and so it will be 2, 4, 6, and B will be the let's say another event which is number less than 4, sorry, greater than 4. So greater than 4 will result into 5 and 6. Okay, so these are the two events that we have taken. Now we need to find what is the probability of A union B. Okay, in that case, what is the probability of A first? So you can say the sample space size is 3 and the total number of value is 6. So this is 3 by 6, and plus probability of B, what is this? It is 2 by 6. And now we have to find A intersection B. To find the probability of A intersection B, just need to find what is A intersection B. So A intersection B is the element that is common in A and common in B, which is 6. Okay, so this 6 will be there. So probability of A intersection B will equal to minus 1 by 6. Okay, so this way you can calculate the probability of 4 by 6, which is 2 by 3. Okay, so this is how you can calculate some probability using union and intersection thing. Okay, so intersection means whatever the elements common in between those two events, whatever the common in those two events, take the intersection, and just whatever the number of elements is in A union intersection B, just find the probability based on that. So obviously, still the original sample space is just 1, 2, 3, 4, 5, 6, and I have to find this particular thing by seeing number of element in this particular subset. Okay, which is one here. So this is how you can calculate some probability. Obviously it's not like you can pick up any book. So similarly, like RD Sharma, there's a book of RD Sharma, Objective Mathematics. So probability section is good there, because you'll find a lot of questions related to probability section. And particularly for random variables and distribution, I would suggest one other book. But for probability, that particular book is good, and you'll find a lot of different questions. Okay. And similarly, just like you can extend this particularly same idea on the large subset of element. So let's say we have now three event A, B, and C. So just P of A union B union C is, like in set also we have this formula. So but not in the term probability, but number of size of set. So P A union B union C is written as P of A, P of B, P of C minus P of A intersection B, P of A intersection C, B intersection C, and P of A intersection B intersection C, but is added. So like if you will see this particular thing in terms of Venn diagram, you can see that this is A, this is B, and this is C. So this particular thing is actually counted thrice. Okay, because this is also part of A, this is also part of B, this is also part of C. So that's what we need to do. And this particular thing is counted twice. So whenever we are just having intersection of with two set, we are removing that particular thing again. But like removing those particular things thrice actually completely remove this three thing, completely remove this three thing. That's why I need to add this thing. So if this just an intuition, but if you don't understand also, you can always apply the formula. Just find what is probability of A, B, C, just the way I suggested, and you can find this particular event. It may happen that like the way is defined with this example. So it may happen that you defined A as a number less than 4, so it will be 1, 2, 3. And B, you define some other probability event as even number, it is 2, 4, 6. And C, you can define a number less than 5, which is 1, 2, 3, 4. And just you can find what is the probability of A union B union C. So this is the way you can do this particular thing by taking different set of examples. And if you are new to probability, then try to do a lot of questions, because whatever data science exams you're preparing for, whether it's CMI, ISI, you actually need a lot of practice of probability. That's why I'm telling you, if you're new to this question, just try to practice the basic from RD Sharma, and there are a lot of advanced questions also given that you can see. Okay, and then you can solve the previous year questions. So now at this point of time, we just need to discuss the complementary event. Okay, so I told you ki, like yeah, let's say A is, like if S is your 1, 2, 3, 4, 5, 6. This is let's take original S, and let's define A as an element, A an event which is number, even number. Okay, so it will be only 2, 4, 6. Okay, so this particular thing, if you find A complement, okay, it will give all the elements that are in A but not, sorry, that are in S but not in A, which is 1, 3, and 5. So, like if you find probability of this event, it will be 3 by 6, and if you find probability of this event, it will be 3 by 6. So, in general, if we say that A and A complement are a complementary event, then what happens? Probability of A plus probability of A complement is equal to 1. It means when you take the probability of both the event, thus A and A complement, and if you add those particular probabilities, you get the value of 1. That's how you concluded this particularly things are the complementary events. Okay, and this is a simple thing. So let's say anyone asks you that, okay, probability of A is, so this is the probability that you need to learn. So probability of A is 3 1 by 2. So what is the probability of A complement? So just need that, we only need to do 1 minus 1 by 2, which is 1 by 2. If anyone says the probability of A is, what, let's say 4 by 7. So what is the probability of A complement? You know that just need to minus those particularly 7. So probability of A complement will be 3 by 7. So this is the property that you need to learn. So these are the three property, and actually having for different types of event. If you have two events and asking what the union, just apply this formula. Three event, apply this formula, and complementary event, you can just always need to remember this formula. Okay. Okay, so at this point of time, let's now discuss some difficult, some challenging problem, and let's now discuss those particular thing. Okay, so let me discuss this thing. So it's saying that the probability of an American industry will locate in Shanghai, and Shanghai, China is 0.7. Okay, so there is an American industry to, so let's say now we are defining it particularly event Y. So Shanghai and China, that will, the industry will locate to Shanghai, China is E1. Okay, the probability of E1, what it's given at, which is 0.7. Okay, the probability that it will relocate to Beijing. So this particularly event we just define it by E2. Okay, so what is the probability of E2? Probability of E2 given is 0.4, and the probability that it will relocate to either of these things, matlab either means, see, there are two things in the probability of set. It's either and. So if it's either, it is talking about union. Okay, A union B, either B, or it can be both also. Okay, and if it's talking about and thing, just it's talking about A intersection B. So whether whenever you find either, just think that it's about talking about A union B. Either it will be A, or either it will be B, or it can be both. So probability of A union B, how much it is given? This is given as 0.8. So what is the probability that the industry will relocate to both cities? So both cities means it is asking the probability of simultaneously relocating into both cities, which is A intersection B here. Okay, so to find this particular thing, the main formula that you need to apply is this A union B. So you know that particular probability of A union B is actually the simple thing that we discussed: the probability of A plus probability of B. But like this particular event questions cannot be only in the term of like I different dice or coin. It can be in the form of some real life problem also. Okay, so this particular thing is given. So you need to find this particular thing. So A union B is given, which is 0.8. The probability of A is given, which is A obviously is here E1, which is 0.7, plus E2 is 0.4, minus this particular thing, let's say, is X. So this particular thing comes as calculating of 0.3. Okay, so this particular thing calculated to 0.3. So what is the probability at both cities? It will be 0.3. Okay, sorry, 0.3. Okay, so this is how you actually do need to do some calculation. Obviously, like any probability will always be between 0 and 1. So this is a some thing that I don't need to say you. So probability, anything probability can be between 0 and 1. Okay, so the second question is neither city. So probability of A intersection B is in both cities. Okay, in both cities, and it has no, it's neither cities, neither it's A, neither it's B. So you can just need to some modify this particularly event in this particular neither city. So neither city means nor A nor B. Okay, neither A or B. So how you can do that? You can do that in this particular thing. You can calculate by minus. So let's say this particular thing event by A. Okay, so I was telling ki just 1 minute. This particular thing. Okay, so A intersection B means both A and B, and let's do this particular thing: A intersection B ka complement. Okay, so this particular thing means either A or B, neither A nor B. Okay, so if you just try to find probability of this particular thing, so let's understand by using this Venn diagram. So this is A, this is B, and this particular thing is A intersection B. Okay, and if it's neither A nor B, it means that it is talking about everything that is outside A and B, everything that is talking outside A and B. So it cannot be either A, it cannot be B, or anything is there. So simply means it's talking about anything that is out of your A union B. A union B, anything that is out of your A union B. So this particular thing you can calculate by, I told you, this particular thing. So let's say there is a event A and there is event A complement, and there is both probability will be going to be 1. Okay, the both probability will going to be 1. So this thing you can do that ki A union B you can calculate by 0.8 we already given, and this particular thing actually means that everything that is not in A union B. So it's 1 minus P of A union B. Okay, so this thing will be your 1 minus 0.8, which will be 0.2. Okay, this will be your final answer. So basically, like this thing can be also done using the set, and like in set there are some complex formula which is I think called de Moivre's theorem. So let's we have to do this particular thing, but like you can just do change those events in the terms that you already have, and you can then find the required probabilities there. Okay, so this A intersection is neither CTA nor B. So it obviously it's the what you can say, it's a complement of this particularly A union B, because A union B is either A or B, obviously. So then complement of this particular thing, which is 1 minus B union B, is neither A nor B. Okay, so till now we have discussed a lot of things related to probability, but let's now discuss on the conditional probabilities. Okay, so the conditional probability of B given A is denoted by P of B given A. Okay, so let's say there is a event B and there is event A. So probability of conditional probability of B given A. So B given A is written as B given A. So it is all about happening of B when A has already happened. So this is the conditional probability. So conditional probability means it is actually depend on some other event. Okay, so let's say this A is some other event, and we are trying to find the probability of B when A has already happened. Okay, so this particular thing is written as this way: probability of B given A, and its definition is probability of A intersection B divided by probability of A. Okay. So this is how we calculate the conditional probability. So conditional probability means simple thing. You are trying to find probability of B when the event A has already happened, and this is actually conditional on A. So that's why the B is being conditional on A. This is called conditional probability, and this particularly thing is actually written as probability of A intersection B divided by probability of A. Okay. So this is how we actually compute a conditional probability. The overall idea behind the conditional probability is that ki just trying to find the probability of given event based on some other event. So based on some other event A. So that's why I'm telling you the probability conditional probability of B given A is denoted probability of B given A, and it's represented as this way. Okay. So means you just need to understand these things, for example, and actually the book that I am following till now is actually did not have a lot of example, but in the next class we'll be discussing these things in detail by with some examples. So just let me introduce this concept first, and then we'll discuss this thing with the help of example. Okay. So so one how one may understand the conditional probability. So let's say you have an event A. So event A is even number in the tossing of a die. So it will be 2, 4, 6. Okay. And event B is, let's say, a number less than 5. Okay, so it is 1, 2. So someone may ask, what is the probability of B given A? So B given A means what is the probability that the number is, so this is number less than 5. So number is less than 5 given A has already occurred. So A has already occurred means there is already we had an event, which is there is an even number being drawn from the dice. Okay. So probability of B given A means there is an event A which is already occurred. So we know that the probability of happening of A is means the event A is drawing a even number from the dice, and we're trying to find what is the probability of B if A has already occurred. So we know that this particular thing is represented by this formula, probability of B intersection with probability of A. So it means probability of happening of B when A has already occurred, and we are trying to find this probability. So A intersection B means what is the common element. So these 2 and 4 are common element. So there are only two elements. There will be 2 by 6. And what is the probability of A? Probability will be 3 by 6. Okay. So the overall probability will be 2 by 3. So probability of B given A will be 2 by 3. Okay. So this is how you calculate the conditional probability. It can be based on any other event also. It can be model into some complex example also. But obviously the overall idea is to apply this formula to control the find the probability of A, B given A. Similarly, there is a something called independent. Okay, so two event A and B are called independent. Independent means they're not dependent of each other. Only when probability of B given A is equal to B, probability of B, or probability of A given B is probability of A. So why this thing is there? So it means, let's say if they are independent, then obviously probability of happening of B when A has already happened should not depend on A, because both are dependent. Okay, both are independent. That's why I'm telling you, if both the events are independent, then probability of happening of B should not depend on A, and that is actually precisely what this statement is telling. If you find probability of B given A, or if you just find probability of B, both the number will be same. Both the probability will be same, and And this is how it's defined the independence of event. Independence means simply B is not dependent on A. So obviously, if you find this particular probability B given A, so it should not depend on A. And that if it's not depend on A, that number should only be probability of B. So that's how this particular thing is interpreted in terms of real life, and we'll see some examples also in the next class or maybe in this class also. So independent means simple thing, no any dependency. That's why probability of B given A means what when the B is happening, it should not depend on A, and that's why the probability should be equal to probability of B. This is the precisely definition of independent event. Okay, so there is some example there, but I think we'll discuss this example in the next class. And and then we'll discuss this product rule and some other rule in the next class also. Okay, so we will see some more examples in the next class, and precisely we will start with the some examples of conditional probability and probability, and then we will have the further discussion. So mainly we discuss conditional probability, we discuss some total probability theorem, and then we discuss Bayes theorem. And so in the next class we'll discuss this particular thing also, Bayes theorem also we'll discuss, and then we will also discuss some examples based on this particular thing, and then we will enter into the random variables. Okay, random variables, then we will discuss.